Hello everyone, I'm Vivek from K4 Metrics and we support SmartUQ in India. In part 2 of our Spatial Temporal Emulator series, I showed how to create the Spatial Temporal Emulator. So we took 5233 grid points, that is for the complete airfoil. In this video, what we'll do is I'll show you how to predict new outputs for new combination of inputs using the Spatial Temporal Emulator, and how you can use Tecplot to take the results from SmartUQ and plot the contour. So here I have opened the result file from my SU2 solver, and for this video, in order to compare the prediction with the actual result, so we have taken a smaller grid quantity. So what you are seeing, this red color rectangle, so the points within that, so we have taken about 1100 points. So with this, I'll just shift back to SmartUQ. So here we can see we have taken 4 slice details. This is the output that it contains the density values for 4 slices, and these are the input parameters. So for these combinations of inputs, these are the density values. And as I mentioned in the previous videos, each row depicts a separate simulation run. So we have taken 60 simulation cases here. Now coming to the grid coordinates, as I showed in Tecplot, we have taken 1132 grid points, and these are the x and y coordinates for it, and this is the point ID of those grid points. Now here I have taken another thing, that is the details for slice 5 run 1. These are the input parameters for this. So what we'll do is we'll create the emulator and we'll predict the density for this combination of input. Now what I have loaded in Tecplot is the actual output for these same input parameters. That is, this is the contour for those, the density for those input parameters. So now I'll have to create the emulator for this combination. So for that, what I'll go to emulate spatial temporal emulator. So X matrix, I don't want the slice details. So I'll just only select the input parameters. For the output, again, I do not require the slice number. I'll only keep the density values, and here I'll be selecting the grid coordinates. So this is a 2D case. So I'll only be having the XY data. So with this, I'll go ahead and create the emulator. So at the bottom, it shows the progress of the emulation creation, and you can also see the same if you go to the jobs section. Okay, so I had paused the video so that it could get completed. So you can see here that it took 38 seconds to create the emulator for this set of data. So here I have the emulator with me. So now what I'll do is I'll go to the emulator, and as I mentioned, I'll predict the output density for this combination of input. So we'll go back to emulator, go to next steps, predict. So here I'll select the sheet 1 data. So here I have these 5 things where I only require the input parameters. So I'll ignore this slice and run details, and I'll have to select the grid points for which I want to predict. So here I'll again select the x and y coordinate. So you can see that I obtained the density for this input parameter almost instantaneously. So this is, we have taken one simulation run, so you can do the similar kind of predictions for hundreds of thousands of simulation runs in a matter of minutes. So if I go back to the jobs, so you can see that the prediction took just 2 seconds. So now what I can do is I can save this prediction as a CSV file. So I'd like to show the file explorer. So what I've done is I've saved this CSV file with the name prediction 4 and to Tecplot. So I'll show this in Excel itself. So what I've done is I have taken the output of density, I have transposed it such that it comes as a column instead of row as how it was in SmartUQ. Along with that, I have also added the same point ID and x and y coordinates for the grid points. So this is the file that I have done. So why I have added these things is because we have used a Python script to add these points to the grid in Tecplot. So we are using PyTecplot, which is the Python API for Tecplot. So once I have the output ready with me, so here I'll show you the Python program. So this is the Python program we have written where it adds the values at each node. So it reads the prediction 4 to tecplot.csv, and then so once it adds the values, it adds under the variable name PRAD for density, that is prediction for density. So this also writes two log files. So what it is one log file will contain details as to what this Python program read from the CSV for a particular XY coordinate, and the log file 2 will contain what this Python program assigned in Tecplot for a particular XY coordinate. This is because so that if we subtract log file 1 from log file 2, we should get the value as 0, which means that it has perfectly assigned the values at the correct locations. So before running, I have to turn on the accept connection option. So I'll go to scripting by Tecplot connection and accept connection. I'll come back to, before that I would like to just show this probe option. So I'll just probe at a particular location, and here you can see the values of all the variables. So you can see that I have the original density value which I got from SU2, and the prediction for density is still not loaded here. So I'll go back to Thorny and I'll run the script. So here you can see it has ran the script for the frame 001. So now if I probe at some particular location, so you can see that now I have an additional variable that has been added here, prediction for density. So you can compare the density at this particular location. So if I go to zone cell info, so you can see the node number 1103. So for node number 1103, this is the actual output that we got from AC2, and this is the prediction that we got from SmartUQ. So you can see that this is close to the original value. Now it is contouring the original density value. So what I'll do is I'll go to the contour details and I'll change this to prediction for density. So now you can see the comparison between the contours here. So it is very much accurate and it is very close to the original prediction of from SU2. So this concludes this video. If you have any questions, drop a comment down or reach out to us at support@k4metrics.com.